Hi! So today we're going to talk about 5 different types of movement: abduction and adduction, 2 examples of flexion, protraction and retraction, and lastly, rotation. So let's start off with abduction and adduction. For this example, we're going to use the glenohumeral joint. Shoulder flies are an excellent example of this, where the abduction occurs as your humerus is moving away from your body laterally, and then So first we're going to start off with abduction and adduction. This can occur in all areas of your body for the most part, but for this example, we're going to use the glenohumeral joint. The abduction occurs as the humerus moves The abduction occurs as the humerus moves laterally away from the body, and then the adduction occurs as the humerus moves medially towards the body. So shoulder flies are a great example of this exercise. It's a frontal plane movement that occurs in the sagittal axis. Next, we're going to move on to flexion. We're going to talk about flexion as a frontal plane movement and as a sagittal plane movement. So starting off with frontal plane movement. Starting off with frontal plane movement is flexion of the lumbar spine. Pretty much any exercise that really targets your obliques, you're going to have this type of movement. So here in the example is a dumbbell. Side bend. So here in the example is a dumbbell side bend. You can see that the body is moving away from the midline, again in the frontal plane and the sagittal axis. Next, we're going to flip those two around. So we're going to have sagittal plane in the frontal axis, and that would be in our knee joint. Next, we're going to flip those around and show the same. Next, we're going to flip those around and show how it can be a sagittal movement in a frontal plane. No, we're not. It's an axis. Next, we're going to flip those around and show how you can have this same movement in the sagittal plane and the frontal axis. A squat is a great example of this. You can see how your body is moving into the sagittal plane, and you can see how your knees are fixed, or the fixed point for the axis. Sticking with sagittal plane movements, we're going to talk about protraction and retraction of the shoulder. Sticking with sagittal plane movements, let's move on to the protraction and retraction of the shoulder. I always want to say griddle, but it's not a griddle because you don't cook pancakes on it. Sticking with sagittal plane movements, we'll move on to the protraction and retraction of the shoulder girdle. Rowing, or in this case, cable rows, is a great example of your shoulders protracting and retracting. Again, like I said, this is a sagittal movement, and sagittal movements occur in the frontal axis. Killed it. Next, we're going to move on to rotation. And for this, we're going to use the hip joint as our demonstrating point. Next, we're going to move on to rotation, where we're going to be demonstrating. No, don't scratch yourself. It's weird. Next, we're going to move on to rotation. So the medial and lateral rotation of the hip. Personally, I had sort of a harder time determining the difference between rotation and abduction and adduction of the hip. So finally, I just sort of had to say to myself that rotation is more the rolling of your hip joint, and abduction is more the medial or lateral movement of kind of your entire leg and your hip. So for myself, I chose clams as an example. So I chose the clam exercise as an example of this because your feet stay together and you're more kind of rolling the hip to open up. This movement is quite a bit different from the others in the fact that it takes place in the transverse plane and a longitudinal axis. So lastly, we're just going to touch on tensegrity and my tensegrity model, which was a lot more difficult to make than I thought it was going to be. My understanding of tensegrity is that for a long time, our bodies were sort of thought as Jenga blocks, just all stacked right on top of one another, which I guess in theory we kind of are. However, if you think about a giraffe and their long neck, if that was the case, the giraffe would never be able to hold up their neck or reach for, Thomas? Thomas? Can you close your door, please? Can you close your door, please? Lastly, I'm just going to talk briefly about tensegrity, or as briefly as possible about tensegrity. Our bodies are often thought of as Jenga blocks or building blocks, just kind of stacked one on top of one another. I think that's a great starting point, but when we really break down how we're built, our bones don't touch like Jenga blocks touch. Our bones are more floating within a surface of connective tissues and different kinds of joints and cartilage and all these other types of things. So, for example, a giraffe with their super long neck, if it wasn't for tensegrity, wouldn't be able to stretch and bend and move and really function the way it does because it would just be neck bone on top of 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 neck bone. So to really kind of demonstrate how the bones are connected, we have something called a tensegrity model. So the dowels and the pins, but mostly the dowels, represent the bones, and then the elastics are the connective tissues. So pretty much you can see that these bones are pretty sturdy and everything is still pretty sturdy even though the bones aren't stacked. No, that doesn't make sense. The tensegrity model really sort of helps demonstrate that theory of just being sort of floating bones that are connected in the fact that the dowels are the floating bones and the elastics are the connective tissues. So I guess the next question would be, why is it important for us to think of our bones as floating and then the connective tissues, as sort of holding us all together? Previously, we had learned about gait and posture and how someone's gait can really show you, I guess, the faults in someone's body, maybe a sore hip or an injury or whatever, because we're making up for it in the way we stand and the way we do all these different activities. The Tensegrity model really helps us sort of understand that. Whereas if you pull two parts, all parts pull apart. If you sort of squeeze one part together, it affects everything. You'll notice when you squeeze this, all of this stuff moves and shifts to the side. So it really helps us kind of get an inside look at what goes on when our body isn't functioning in the way it should be. Like just a normal Tensegrity model, if something is, no. If that snaps on me, I'm going to be mad. Let's just wrap that around. Except now I just messed it up. Oh my God, please don't break. If this was somebody's body, they've seen some things in their life, that's for sure. Okay. So lastly, we're just going to touch a little bit on tensegrity. I'm going to do as quickly as we can because it's a big subject. Our bodies are often thought of as Jenga blocks, just sort of stacked all one on top of another, which I guess is kind of a good way to view it until you really want to break down and know how our body works. If you look at a giraffe, for example, with its long neck, if its bones were just stacked one on top of the other, it would never be able to reach down to get a drink of water or reach up to grab the leaf at the very top of the tree. It's more that our bones are floating, and then there's a bunch of tissues and things kind of holding them together. The tensegrity model definitely helps demonstrate that in the fact that the dowels would be bones, and then all of these little elastics would be the fluid and the connective tissues and the, all that stuff that holds together the different bones. Previously, we had talked about posture and how when you look at someone's posture, you can kind of point out sort of any injuries or faults, for a better word, that they may have. The tensegrity model also helps demonstrate that. So let's say, for example, that you have a sore hip. You're probably not going to put as much weight on that side of your body. So when you're standing straight, you're kind of going to be leaning a little bit to one side. The model shows us that as well, is that if you sort of squeeze one side, the entire model kind of bends and twists and does, I broke it. Hopefully that doesn't happen to your body. The tensegrity model really kind of helps us understand that a bit deeper in the fact that if part of the tensegrity model is altered, the entire thing is altered. And that's same with our body. If you have an injury somewhere else is going to make up for it.